All right, so we're going to talk about vertical problems and the issues you may have when you're encountering vertical problems. There are three. The first is that drop heights aren't negative. And when you solve for stuff like this, you'll probably, when you're doing these problems, you'll usually end up with you're calculating the displacement of an object that's being dropped. Well, that displacement always comes out negative, and the question is like, how tall is the building? So a good example here is number one that I have set up right here. A ball is dropped off a building. It takes 4.5 seconds to hit the ground. How tall is the building? So if we take a look at this, we're pretty much going to draw a little sketch here if we can. All right. Ooh. Let's make that a little thicker. There we go. And what we know is that at the bottom it's 4.5 seconds, and the acceleration is due to gravity. Geez, I can't write. That's negative 9.8. And we know our initial velocity is going to be 0. Sorry, guys, I can't seem to get my pen to work properly. All right, so with this information here, let's write out our givens. Our initial velocity is 0 meters per second. Our time is 4.5 seconds. And acceleration, which is g, is negative 9.8 meters per second squared. And we're trying to figure out displacement. So to do that, the best equation that we have for that is this equation right here. So d equals v naught t plus 1/2 at squared. Now, because the initial velocity is 0, this whole part of the equation goes away, and we get displacement is equal to 1/2 times negative 9.8 times the time, which is 4.5 squared. And so if we punch that into a calculator, we get 99.2. We get a negative 99.2 meters. Now, here's the issue. Because it's negative because we calculated the displacement of the ball. We didn't calculate the actual height of the building. So when we circle our answer, we have to realize that our drop height is not negative. This was the displacement of the ball right here. So the height of the building is 99.2 meters. Okay, that's supposed to be meters. Sorry. Hold on. Erase. Try that again. Meters. Slightly better. Okay, so that is how we would handle our first issue. Now, our second issue is, as you can see up here in number 2, right there, is that impact velocities are negative, but your calculator will often give you a positive root. So if we take a look here and we say with the same drawing, but this time we know our final velocity, or excuse me, we're asking for a final velocity, but we do know our displacement. Now, our displacement of the ball was a negative 99.2. All right, so if we use this equation here, VF equals V squared, equals V naught squared plus 2A delta D, all right? Again, our initial velocity goes away. That's very nice. So VF squared is equal to 2 times a negative 9.8 times a negative 99.2. And when we punch that into the calculator, we get like 1944, but I'm going to square root that all in one step real quick. And so when we square root that, so VF, after we square root it, my calculator spits out 44.1, and then the units would be meters per second. Here's the problem with that. The problem with that is the ball is moving down. So what you got to realize is when you plug this in, you're taking the square root of, sorry guys, can't draw that. Taking the square root of like 1944, like I said. What actually this is the actual square root is plus or negative. Sorry, my pen does not want to write for whatever reason. Let's try that again. It is the positive or negative 44.1 there we go. There, you can kind of tell that's a 44. That's supposed to be 44.1. There you go. It's actually a positive or negative 44.1 is the actual square root of that. So you're going to have to use your own judgment and realize that that's negative, and you're going to have to change that to a negative when you do that. Okay. All right, we're going to stop for here, and then we will do part 2 in just a moment.